Dear friends, dear colleagues, a very good evening to you all. My name is Nanuli Popkhadze. I am with the Finance Division of Sberbank. I'm happy to welcome you to our session on AI in finance. We've got a bunch of great speakers from MTS, Sber, Microsoft, Teradata, and many others. We are going to discuss investment in AI, the ROI on this investment. You must have heard that McKinsey forecast of additional value creation of $13 billion until 2030 coming from AI. Should be $1 trillion, right? $13 trillion. So we'll look at specific cases of how AI can improve business processes, but also we'll talk about ethics and responsible use of AI.
So, process mining in Sber. In our talk, we would like to tell you about three things. First of all, I will tell you about process mining and why do we need to do that. Then Alexander will tell you about our products, and we will take your questions in the third part of this talk. So, process mining is a methodology for analyzing digital trails of users to map business processes and to show the real state where the saving potential is and where the profit potential is. This is extremely important for the process owners. The main reason why is that it's about performance, it's about productivity, and in the end it's about money. Since we are part of the finance division, we are committed to driving the best cost income for the company, and this is relevant for any commercial organization on this planet. Historically, the whole idea of making more at lower cost was introduced to business many years ago. It all started with Taylor, who proposed some standards for managing performance. Then there was mass production, then there was Toyota's Lean, which was followed by the Six Sigma BPM. Today, all those tools which were extremely efficient just 5 to 10 years ago and which were based on time measuring, Gamba, expert interviews, they are no longer as efficient as they used to be, especially for such large corporations as Sber. We have tens of thousands of business processes, and describing them using those methods would take too much time. That is why we need to use automated process mining technologies. There are 4 key scenarios for process mining. At the stage of process discovery, we map the process as is, and we do all the analytics. At the second stage of conformance checking, we check whether the digital trail for the process complies with the formal description of the process. Then, at the enhancement stage, we model and improve the process, and this stage is followed by the intelligent monitoring stage. Let me illustrate that using the practical example of our loan factory for issuing loans to small and medium enterprises. So when we started analyzing the processes, we found out that the process takes too long to complete. It takes 4 days from the application to the final decision. So we had to straighten that out. Then, in the bottom part of the screen, you can see the performance map for different regions. And here an interesting insight was that in the Russian Far West, the speed of issuing loans was much higher than in Moscow or St. Petersburg. Plus, we took all the correspondence between our loan officers, lawyers and underwriters. We analyzed the text of those emails to identify the 5 most important reasons which slow down this process. Then we checked whether this process conforms with the initial idea behind it, and it turns out that it doesn't conform at all. So on the left-hand side you can see the ideal map of this process, but on the right-hand side you see what it really looks like in practice. Too many loops, too many approvals, too many checks. Then we converted this graph into BPM notation and sent it to ARIS, our business modeling system, so that we could automatically check whether it complies with the regulation or not. But you know, we have never seen a business process which would absolutely comply with the regulation. So this proves to be quite a useful exercise for identifying the deviations. After that, we went on to the enhancement stage. We identified all the inefficiencies, we identified the non-conformance with the process regulation, and then we can collect all the insights and perform the what-if scenario. So if we reduce the loan approval time, how much money it would give to the company. And at the last final stage, we can start the intelligent monitoring of the process. So in this loan factory, after 3 to 6 months, once this process has been completely straightened, we can check whether it has really helped to improve this process and bring it closer to the desired state. And this stage is also used by Sber for analyzing various changes. So that's the approach we use across the corporation, and it works perfectly. The only prerequisite is to have the reliable data for digital trail analysis. And I would like to pass the floor to Alexander. Alexander, besides working for Sber, is also a professor of process mining at the Bauman Fiztech University. As Nanuli has said, process mining is an analytical system, and as any analytical system, it starts with the data. The main data we use here is collected from event logs, which are generated when users do something in those systems. So those logs contain certain sequences of actions. Usually in the logs, there are 3 types of items: the ID, the transaction, as well as the timestamp when this transaction was completed. So process mining is essentially built around these 3 entities, and we can already start using it for our business analysis, but usually there's more attributes in the system, like products, responsible persons, and some additional free text fields, like email communication on this or that transaction. So any process mining system should be able to process structured and unstructured data. As to the structured data, it contains lots of specialized terminology. it contains lots of acronyms, so we can't simply use any system from the market out of the box. We would have to customize it to start using it for our business processes. As to the structured data, well, here we use such data visualization tools as AlphaMine, DFG, and heuristic miner, as well as other tools for highlighting anomalies. All those algorithms are implemented in two main tools, Sber process mining and Sber process mining library.
So we also have machine learning toolsets and also tools for text analysis, such as clusterization and case summation tools. Our platform is effectively a tool for analysts, which is coding-free, zero-code tool. It actually covers the full cycle from feeding data into it to reconstruction. So it obviously includes automated graph reconstruction, factor analysis, text analysis, change management, as well as data representation on dashboards. The kernel of our system is SberPM Python library. Effectively, it is designed for data analysts and data scientists who want to code on Python. It includes all the algorithms you will find in the core product, but also some experimental features as well. When we developed this product, we wanted to make it a local open-source tool so that every data scientist, every analyst was invited to either send a pull request or come up with a proposal in some other manner. This is how we very quickly beefed up the functionality of the system. And we are happy it was, tested and proven to be very useful. So it also includes some modeling tools. So, it's pretty strong in terms of process modeling. There are numerous algos in this library, and some of them are considered experimental. Unfortunately, I don't have enough time to tell you about them in detail, but I'm happy to invite you to our bench, or rather our booth at the conference, where we can tell you more about the specific methods that we used. This is it for me, and I hand it back to Nanuli. Thank you very much, Alexander. I already see two questions for you. And naturally, one of them is the most popular question. It's about money and the particular monetary benefits of process mining. Another quite popular question as well is about the way we deal with data. So let me take the money question, and the data question will go to Alexander. So we've got 2,100 processes in the bank, and we are talking here about large-scale processes that tend to be quite expensive. So when you are developing a tech like this, technology that enables you to quantify processes, to see how much they cost, naturally, you will use it to identify the costliest processes and apply automation where it will have a maximum benefit possible. So based on our experience, I can tell you that up to 10% of process costs can be shaved off with AI. Data, sure. Now, it's actually a question about data quality. It's primarily a question of your data culture, because in most companies, data will be logged in a certain automated system. There is no end-to-end system that would enable you to reconstruct a particular process from several automated systems. And we can relate to this problem very easily. We understand how important it is to consider the linkage of several systems, because usually problems lie at interfaces of systems or departments. If you don't have an end-to-end ID, you can actually use ML to develop an algorithm that will help you connect the data. So based on our data and based on our practice, we know that up to 70% can be connected like this. So process mining is very useful in this respect.